paper, they're just showing you different ways to come up with these Latin squares, like you were asking how to arrange. Here's a way to arrange them differently. And so it's just a way to try to arrange these treatments in the square to randomize them. If you're interested, it's on there. And then one of the things I've got here is example 3.1. So example 3.1 is the driver and the car thing, you know, where you've got just what we've been talking about the whole class. We've got 4 drivers and 5 cars, and we were looking at the gas mileage. And the question was, the real question we wanted to answer was, did the cars matter with gas mileage, not the driver? But because of circumstances or whatever, we've got, you know, we can't let one driver drive everything. And so, let's see, looking at it, you think, it does look like cars matter. I mean, this one seems to be lower kind of consistently, but here's a high value, sort of, you know. It does look like it matters. So this one is very appropriate for this block thing. Now, one of the things I like to do, let's suppose you didn't know that. And let's suppose that we didn't even have this column, and this is just presented to us as data, right? Here's 4 different tests of each of these 5 cars. So I did that. Let's do an ANOVA with ignoring, let's do the one-way ANOVA, right? Let's see, here, yeah. So let's do the one-way ANOVA. So here's the treatment, and here's the regular error like we did. So this is just the one line that we care about, right? The one line up here, is F bigger than F critical, or is the p-value small? And so if we just selected that table, did the single factor ANOVA, ran it, and said, is there a difference in the cars? Our answer is no, right? F at the 5, I think I did 5, I always do 5%. So F at the 5% is 3.06, and our F calculated was 2.2. We're way over here. Our p-value is almost 11%, right? Yeah. So the answer is no, the cars all got the same gas mileage. Because we've confused it, right? We've got these different drivers that, you know, some person had a lead foot, went around, made all the cars have low gas mileage, or especially some of them maybe that were, you know, had big engines or something, and somebody was driving like a snail carefully, and so they all looked good. So that's wrong. And now again, like we were talking at break, you might have to stop here, because if we didn't, when we did the test and we didn't write down which driver drove which car, we're done. You know, we're like, well, I'm sorry, I can't tell you that. I can tell you that we didn't get anything out of this experiment, perhaps. Perhaps we might be the cars don't matter, but probably, you know, you're thinking they don't. They do. I'm thinking they do too. So what did we do wrong? Well, we didn't write down the drivers, or maybe we were really stupid. We didn't drive on the same course or something like that. But hope to goodness they weren't that bad. But if we did write down the drivers, we can put them in blocks. So now we can go in here and do the 2-factor ANOVA without replication. And I did it 2 ways, the reason why you see 2. I told you what I did. In this case, I didn't put the labels just so you can see. I told you it just generically calls them row 1, row 2, column 1. But if you select the labels, well, and I didn't do any good. I didn't name them different. I should have at least done the drivers A, B, C, D. So, but this is the drivers, obviously, this is the automobiles. Remember the summary table, and then the results. Of course, the 2 ANOVA tables are going to be the same because they're obviously the same. It's just whether they were labeled or not. But if you look at the ANOVA table, yeah, now you can see, yeah, the drivers did matter, and the cars did matter, in both cases. So we were able to, by splitting it up and partitioning our error, you know, and not just partitioning the error that way, but including that term, we were able to say, yeah, we could compare this to that and that to that, and say there was a difference. And yeah, there was. There's a difference in the driver, and there was a difference in the car. And so you can see why you would want to do this, why you would need to do this, and why it matters. You know, and this table, well, I said it. I think it should look like. Yeah, page 47. Yeah, table 3.1 on page 47. Let's see. Or no, that's the data. Oh, that's for the data. Yeah, they ran the ANOVA They presented the data, then they ran the ANOVA way later. Yeah, there they did it on page 3.3 or 3.3, the table 3.4. That's it, isn't it? Yeah, yeah. Yeah. So, okay, so now let's see. Yeah, that's table 3.
So, these are the things.
Yeah, okay, yeah, so table 3.3, that's it. Yeah, there it is. Okay, yeah. So there's that, so now let's see. And then what else? And then I've got example 3.5, I think, too. Yeah. So now example 3.5 is the one we were reading in the book where they had the stores. So example 3.5, they have the grocery stores with the 4 different products and 4 different manufacturers. So it's a Latin square, 4, 4, 4. So we had the different brands were this way, items were this way, and the stores were this way, I think, in their layout. Supermarkets, yeah, A, B, C, and D. So the supermarkets are the things that were arranged within the block, different items this way, the different brands. Okay, and so I did the same thing as the Dura paper. I used their math, because remember I said Excel doesn't have a Latin square function, a mini-tab. Good.
So Dr. Kress?
Yeah.
You know, one of the previous example, you said if we had the basic blocks of data, you know, we could do it mini-tab. Are we going to see one of those examples like in the future?
I'll try to do one. I have not done one for you yet. There's one. There is one in the book. They take the driver one, the cars. Although they don't use the same data, they use a different set of cars, and they show you one. But I need to download mini-tab and do it for you, or do it in MATLAB, one of the two. It's one of the, you know, they said that at the start of the book that that's one of the problems with Excel. It doesn't handle missing data, but
I was just curious.
yeah, I'll try to do one for you because I think it'd be important to be able to figure out how to do it. Or I might do it in or. I got a bunch of different ways. So this is the same calculations that was done in the Dura paper. I did them the same way. So you can tell I use the same spreadsheet. It's got the same colors, and these are the stores this way. And so when you get over here, we saw, let's see, the rows, the columns, the treatment. So we were asking ourselves, did the let's see, the rows were the brands, right? Let's see. That's how it was. Let's see. No difference on average. 4 supermarkets, easy contradiction. So let's see. The supermarkets was the treat. Let's see. Here, the treatments. That's right. That was a supermarket. And the rows. Yeah. Okay. Yeah. So the rows mattered, and the brand didn't. Okay. So here was our F. Oh gosh. Here's our F critical at 5% or 1%. So the rows was the item. So the item, you know, you think, well, goodness, of course the items matter. You know, we had steak versus, or whatever, we had cereal versus sour cream or whatever. Of course there's a difference in the items. Those are a blocking variable. But it's nice to see that, probability that, that it was 0. So the P way out for the items, they mattered. The columns was the brand. Remember, the brand might have been, you know, General Mills or, you know, Kellogg's cereal or whatever, and that had a P of 20%. So the brand didn't matter. And then the treatment, that was the things that appeared in the squares. That was the grocery store chain, and it had a probability of 0.2. So the grocery store chain did matter. So we looked at three factors. We had the item, that didn't matter. We had the brand, did matter. I mean, the item did matter, the brand did matter, and the store did matter. So that's, and then this is the one I said that showed you how to calculate the P. So the P, there's two ways to do it. You can do, you've got, remember, if you just calculate, I'm getting a good collection of the bad pens over there. We're going way up in class. So the P is at F dot dis. And F dot dis, remember, like the other distribution functions, it gives you the area to the left. Okay? So if I want P, I have to have P equals 1 minus the F dis value. Because I'm looking for this out here. Remember, the total area is 1. So if I'm wanting this area in here to be my P, the F dis is going to give me this. So I have to tell you the total area in this whole curve is 1. So in order to get the P, I either have to have 1 minus F dis, or they have this other thing, F dot dis RT, and the RT means right tail. So F dis gives you the left tail, even though it's not much of a tail, it's a glob. And the F dot dis dot RT, right tail, gives you this, just the right portion. And so you can either take 1 minus F dis or use F dis RT, which is similar. So that's all I'm doing here, and I'm taking that, and you can see, here, I'll click on it, and you can see what it is. So it's saying at that F, and with these 2 degrees of freedom, what's this area? And so you can see the other one, like the other one down here, doing the same thing. You know, it says, hey, it's using the same two degrees of freedom, obviously. Well, not obviously, but yeah. Well, yeah, it is in this case because of the way the numbers are, and then the F for that one. So it's just so it's asking the question, given some F value, what's the area either here, F dis, or over here, F dis is right tail. So either way, again, and it depends on how you want to express it. Do you want to compare a number to a critical value, or do you want to talk of a percentage? And if you do compare your number to a critical value, remember, you're going to have to pick 1% or 5% or 3% or whatever. Or you can calculate the P, like in this case, and come up with, 18%. And then I don't have to compare it to 1% or 5%. I say, well, 18%, that's big, or 0.2%, that's little. But again, most people say little relative to what, so it's kind of, you can see how it's the same question. So that should be, I think, that's got them all, doesn't it? It's got everybody. I don't have any more things under here. Yeah. And I had another presentation, I don't even think I posted this, because it was too wordy. There was another person doing the same thing, looking at agriculture, and another randomized two-factor block thing. I didn't like that. So hopefully this is starting to gel in your mind. It should be by now, I think. I think this is, and you can start seeing, yeah, I got Tucky and Sheppy to go along with this when I have to go further. And so now we can keep moving. Yeah, moving on to, factorial experiments, where we can do, where we can have only a finite number of levels. So what we're doing there in the future, instead of having 5 levels, maybe we'll have 2 or 3, because there's efficient ways of dealing with those. And again, we're trying to come up with efficient ways of going through large sets of data, as compared to just running through 6 factors of everything. So there's other techniques you can do for different situations, just like the Latin square, different unique situations. So, but you're already way up the line. You've got your tools. You've got some pretty good tools now. Once you got this two-way, you can see why Excel kind of kind of quits there, you know, with a one-way and two-way. You got a good tool now. You can analyze most situations, especially if you've got the ability to control the collection of data. And so you're pretty far down the line. And are there three ways ANOVAs? Yeah. Is there a three-way ANOVA that you can get for Excel? Yeah. There's some free download packages you can get. But I've got a little discussion on that about, you know, a lot of times you're starting to confuse things when you get the three-way ANOVA. Maybe you should have just done multiple two-ways and things like that. So anyway, we'll explore this as we go along. But yeah, have a good weekend, and I'm keeping up with the email and answered the question pretty fast. So if you're having homework problems, just send me an email. I'll get on it. We're done.
Through UT download, we have.
I believe we can.
Do you happen to know how to do that?